Welcome to the DIY Honda Garage channel. Welcome to the troubleshooting guide for DTC B1176, which indicates a short circuit in the fuel level sensor or fuel gauge sending unit in the 2011 to 2016 Honda CRV. The error occurs when there is an abnormality in the circuit that connects the fuel level sensor to the gauge control module. This issue can disrupt the accurate display of the fuel level, leading to potential driving issues. Understanding the components involved is crucial for effective diagnosis and repair. Stay tuned as we explore the symptoms, causes, and systematic troubleshooting steps to resolve this diagnostic trouble code efficiently. The DTC B1176 relates to a malfunction in the fuel level sensor, commonly referred to as the fuel gauge sending unit and the gauge control module. The fuel gauge sending unit is responsible for measuring the level of fuel in the tank and transmitting this information to the gauge control module. It is typically located near the fuel tank. The gauge control module processes this data and drives the fuel gauge located on the dashboard. When there's a short circuit in this system, it results in incorrect readings and potentially activates the low fuel indicator prematurely. Proper understanding of each component's location and function is essential for an effective troubleshooting approach. Several possible causes can lead to the DTC B1176. First, a malfunction of the fuel gauge itself could cause erroneous readings. This calls for a visual inspection of the gauge's hardware. Second, loose or poorly connected wires can introduce intermittent faults. These should be inspected for tight connections. Lastly, a short in the wiring, particularly between the gauge control module and the fuel gauge sending unit, is a significant concern. Such shorts compromise the signal transmitted from the sensor to the gauge, leading to inaccurate fuel level displays. Each potential cause should be methodically tested to ensure the correct issue is identified. The symptoms of a DTC B1176 predominantly manifest through the incorrect functioning of the fuel gauge. One observable symptom is that the gauge may not accurately reflect the actual fuel level in the tank. For instance, it could stop at the full position or fail to rise when fuel is added. Additionally, the low fuel indicator may blink unnecessarily, indicating an alarming situation that might not correlate with the actual fuel quantity. Recognizing these symptoms early allows for quicker resolutions that can prevent driving issues or fuel mismanagement. In this first step of troubleshooting DTC B1176, we focus on verifying the initial functionality of the fuel gauge. Begin by inspecting whether the gauge moves to the full position upon starting the vehicle. Additionally, check if the low fuel indicator blinks. Both behaviors indicate an active problem. If the gauge responds correctly, proceed to the next troubleshooting step. However, if it does not function as expected, this could indicate an intermittent failure in the wiring or connections. An investigation into potential loose connections should follow, ensuring that every connector is secure and free from corrosion. Step 2 involves a deeper examination of the fuel gauge's operational integrity. Begin by turning the ignition switch to the lock position, ensuring the vehicle's electrical components are entirely off. Then, disconnect the fuel gauge sending unit 4P connector to isolate the gauge's functionality. Now, turn the ignition switch to the on position, but do not start the vehicle. Observing the fuel gauge should reveal whether it moves to the empty position. If it does, it signals that the fuel gauge sending unit may be faulty and requires replacement. Conversely, if it does not move, proceed to the next troubleshooting step, as the problem may lie elsewhere in the wiring. Now we move on to the third troubleshooting step, which focuses on verifying the connections in the circuit. Start by turning the ignition switch back to the lock position and disconnect the gauge control module, 32P connector. This action allows us to focus on testing the connections specific to the fuel gauge plus line. Check for continuity between test points using a multimeter. Test point 1 is located at number 22, blue, on the gauge control module, while test point 2 is the body ground. An essential aspect of this check is to see if there is continuity. If confirmed, it indicates a short circuit in the wire between the gauge control module and the fuel gauge sending unit, necessitating wire repair. If there's no continuity, it signals the need to replace the gauge control module itself. After completing the necessary repairs associated with DTC B1176, ensure proper verification of all work done. It's crucial to confirm that any replaced components, such as the fuel gauge sending unit or gauge control module, are functioning correctly. This should include a rigorous test of the fuel gauge to ascertain that it now reflects the correct fuel levels as intended. Observation of the gauge during different fuel levels from full to low will provide insights into its operational clarity. It's essential to ensure that any connectors used are securely fastened and corrosion-free, as this can affect future performance. To prevent DTC B1176 from recurring, regular maintenance practices should be put in place. Routinely inspect all electrical connectors related to the fuel system to ensure they are secure and free from any kind of corrosion. This can prevent minor faults that could lead to significant issues in the future. In addition, implement routine functionality tests of the fuel gauge, checking its response during and after refueling. Consistent checks can serve to identify deficiencies early, allowing for timely repairs before they escalate into bigger problems, ensuring the reliability of the vehicle's fuel system. In conclusion, diagnosing and addressing DTC B1176 involves a comprehensive understanding of the fuel gauge system components, particularly the fuel level sensor and the gauge control module. The systematic troubleshooting process is essential to isolating the source of the issue, whether it be faulty components, loose connections, or shorted wiring. Proper verification after repairs ensures that the solution is effective. Lastly, implementing preventive maintenance measures is vital for prolonging the life and functionality of the fuel gauge system. By adhering to these guidelines, Honda CRV owners can ensure optimal vehicle performance and reliability. Please like and subscribe to the channel. See you next time.